Continuing in 4.3, we're going to talk about logarithmic functions. And so if we can look at right here, if you graph these points right here, they look like something like this. Right, 0, 1, 1, 2, 2, 4, negative 1, 1/2, negative 2, 1/4. So they look something like this, right? And then we have our horizontal asymptote. Our horizontal asymptote right here at x equals 0. Well, if we graph the inverse, if we find the inverse of this, don't we just switch the x's and y's? So we switch the x's and y's. My y's of this one become my x's. Well, why don't we just do this? Switch my x's and y's. This is now x and this is now y. Okay, so now I can graph these points on this graph right here. So this time I go instead of going, I go 1/4, and I go down 2. I go 1/2, and I go down 1, and then I go 1 to 2. Or sorry, 0, 1. Then 2, 1, and then 4, 2. So it looks something like my 1/4 right here is not very good 1/4. So let's fix that. 1/4 maybe right there, 1/2 right here. So maybe that's a little better. So it comes down this way and then up this way. So see that those are inverses of one another. They're reflected about this line, y equals x. And we notice that it doesn't cross this line, right? Because I can't take a log. There's no number that I can raise another number to that's going to get me a 0, right? I can't a raised to what? I guess we put this as y. A raised to what is 0? I can't take any number except for 0 as a base, and that's even called an indeterminate, but we'll move on with that in calculus. But there's no number, positive number, that I can use to find out what that is. So that means I have a vertical asymptote of, this is x equals 0. I might have said this one before was x equals 0. This is y equals 0, right? Because it's a horizontal line, so it's y equals 0. So here I have a vertical asymptote, which makes sense, right? Because my x's and y's, they switch places, right, when I do the inverse. Okay, so logarithms are the inverse of exponential functions. So a few ways to graph these things is just to switch it to an exponential and just graph it. So remember how we switch to an exponential is something that looks like this, right? If I have y equals a raised to the x, well, that's the same as the log. Well, actually, let's switch. Let's go the other way. Let's switch the log. So the log looks like this, equals y. So if I switch that to an exponential, then my base stays the base, and then my x and y switch places. So here's my y now with my a, and this is x. So that's what it looks like, right? So now I can just plug in numbers for y and solve for x. Okay, so that's one way to solve these. Well, the basic format for an exponential looks like this, right? Y equals a to the x, where the traditional log looks like the one above. But if we kind of do standard form of an exponential, it has the negative h on the a, and then we add some k after we take the exponent. Well, the log is kind of very similar, where it is the y equals log of base a to x, but now we subtract h from the x, and that's what we're taking the log of, and then we add some number after we take the log. Or you could rewrite that as y equals k plus, because these are both positive logs and a positive k, plus the log base a of x minus h. Remember, what's inside the parentheses needs to be done first, and then you take the log of that, right? So you're taking the log of what's inside the parentheses. There's a total difference between this problem of x, log base 2 of x minus 1, than log base 2, the log of x minus 1, the quantity x minus 1. All right? So we can go ahead and graph these. And just like on the exponential, what's with k is our vertical asymptote, right? We have, or horizontal asymptote, excuse me. We have a horizontal asymptote at y equals k, right? Well, it just switches, right? My x and y switch places, right? So now it's a vertical asymptote for my log. My log is a vertical asymptote, which is x equals h, or the opposite of this, right? That's what it means by negative h here, the opposite of h, or what's inside, opposite of what's inside there. So we have a vertical line. Okay, so remember when you're asked to graph either both of these on a quiz or a test, that you need to find, for log, you need to find the vertical asymptote. For an exponential, you need to find the horizontal asymptote. And then you need to graph 2 points for both of them. And then after that, you need to make sure when you connect the points that you have that shape of a log, like the one above. And if it's an exponential, you have a shape of that exponential. These shapes, right? And they're in that same kind of form. Okay, so let's go ahead and do some examples, and let's graph some exponential equations. So let's just start out with that one that I just gave you. Y equals log base 2 of x minus 1, the quantity x minus 1. All right. So here, first we start with the vertical asymptote, and that's the opposite of what's with x, so that would be x equals positive 1. Or you can think about, okay, what's going to get this parenthesis to 0? What would I plug in for x that makes that 0, right? Because I can't have that. I can't take the log of 0. So x equals 1. So we can go ahead and graph that. X equals 1. There's our vertical asymptote at x equals 1. Now I have to find 2 other points, and that's kind of a few different ways that you can do it. You could plug in numbers, right? So we know we can't plug in 1. Well, we can go ahead and plug in, say, 2. So that'd be log base 2 minus 1, right? And that's fine, right? Because that would be log base 2 of 1, and 2 raised to what is 1? That would be 0. So I can go over 2 and go up 0. There's my point. Okay, and that could be enough for you to graph, but I'm asking you to graph 2 points. Okay, so how about we just put another one? How about 3? So log base 2 of 3 minus 1 is log base 2 of 2, and that equals 2 raised to what is 2? That's 1. So 3, 1. And that is enough points. So down here doesn't pass that, and it continues. It still is going up. It's just going up at a slow rate, right? So it doesn't flatten out or anything. Okay, so it's still kind of going up there. All right, so that's how you graph a log. So I had my shape, I had my 2 points, and I have my vertical asymptote. Okay, what about this? Log base 3 of x plus 2, say plus 1. Okay, again, I start out with my vertical asymptote. That's opposite of what's in here. So that's x equals negative 2. So we can go ahead and graph that. Oops. Okay, so let's put that in, negative 2. So somewhere, let's do negative 2 right there. So 1, 2. All right, now we find some points, right? So again, we can make a table. All right, so we can make a table. We can put in some x's. So how about, can't do negative 2, and I can't do anything to the left, right? Because it would cross that line. So how about negative 1? Okay, so let's plug in negative 1. So what is negative 1 plus 2? negative 1 plus 2 is the log base 3 of positive 1 plus 1. So what 3 raised to what is 1? That is 0, and then 0 plus 1 equals 1. So negative 1, 1. Okay, now how about if we plug in 0? Plug in 0 for x. So that would be log base 3 of 0 plus 2. And plus 1 after I take that log. So that would be log base 3 of 2. And then add 1. Well, I don't know that answer. 3 raised to what is 2? I don't know that. We're learning in the future, you know, the change of base formula, and that will help us solve that. But I don't know off the top of my head, and then I would have to round, and I would have to estimate where that point goes, right? So I kind of want, you know, some kind of integer, because I can graph those, or whole number, you know. So those are easy to graph. Well, why don't we just put in the next numbers? How about 1? So plug it in 1. Log base 3 of 1 plus 2. Take the log of that quantity, and then add 1 after. So this is log base 3 of 3 plus 1. And that is 3 raised to what is 3? That is 1, and 1 plus 1 is 2. So that equals 2. So 1, 2. So go over 1, go up 2. We have our second point, and now we can graph it. Keeps going up. Okay, so there's our graph. So what you might notice, so that's, again, you can keep on plugging x's till you actually find ones that you can find the log of, right? You can keep doing that. That's fine. That's okay. That works for you. Notice, what number did I circle here? 1. So it's nice when I have the log with any base of 1, right? Because that's always going to be the answer of 0. So you can think about, what should I plug in for x that gives me what I'm taking the log of as 1, right? And then another thing is, I always want the base to be the same of what I'm taking the log of, because that answer is always 1. So log base a of, let's see, what did I say, 1 is equal to 0, right? So any base, taking the log with any base of 1 is always going to be 0, and log of any base of that same number is going to be 1. So those are some easy ones that we can plug in, right? So you got to think, I want my x, right, or this is log base a of x minus h, right, and then plus k. I'll put the plus k out here. So I want this number right here to be 1, and I want it to be a, right, because those are easy answers to the log problem. Easy answers. So if I want my x minus h to equal 1, and I want my x minus h to equal a, then I could just solve these equations, and I need an x. I need to pick an x that is 1 plus h, and I need to pick another x that is x equals a plus h. So then I just take the opposite of this inside and add 1 to it, and that's 1x that I can pick. And then I can take the opposite of this number in here and add my base to it, and I get my second x to pick. So I get my first x and second x, and I can plug those in, and solving the logs of those will be pretty easy, because the logs of those will be 0 and 1. And then I can just graph those points. Okay, so that's one way to do it. Another way to do it is to look at something like this. So let's say y equals negative 1 plus log of base, we'll stick with 3, of x minus 1. Okay? So here what we can do the same thing, our vertical asymptote, right? Always the opposite of this, our x equals h. So x equals 1. You can graph that. Positive 1, say right there. Okay, and then we can go ahead, what we can do is we could switch this to an exponential, okay, and then just plug in numbers for y. So instead of picking numbers for x, we'd pick numbers for y and go ahead and solve that. So first thing, in order to switch it to an exponential, we first have to get this log by itself, right? So I'm going to add 1 to both sides, so that's y plus 1 equals the log base 3 of the quantity x minus 1. And now I can go ahead and switch this to an exponential, so my base stays the same. My x's and y's switch place, right? So these whole things are going to switch places. So now what's with the 3 is the y plus 1 equals x minus 1. Now I could solve this for x, add 1 to both sides. So I have 3y plus 1, then plus 1 equals x. So now I can make my table, but this time I'm choosing my y's first. So how about, what's a good y to pick? How about negative 1? Because that would make 0 there, right? So negative 1. So 0 to the third power is 1, right? And then 1 plus 1 would equal 2, so my x would equal 2. So this is 1 plus 1, so x would equal 2. And so let's kind of look at that real quick. This, my x is 2. Well, where did I get that x from? If we look at our original, that x of 2. Well, isn't that here, right here? My h, the opposite of that, my h was 1. What's 1 plus 1? Isn't 1 plus 1 2? And isn't that what I said down here? Just take 1 and add to your h, and my h was 1, and 1 plus 1 is 2. How about, okay, what's a good, another y to pick? How about a different y than just negative 1? How about a y of, how about 1, right? Or a y of 0. Right. The next one up, a y of 0. So 0 plus 1. 0 plus 1 would be 1. That's a good exponent to have, right? 1's a good exponent to have because 1 raised to the third is 3, and 3 plus 1 is 4. So 4, 0. So I have this point 4, 0. Well, look at my base. Isn't that 3? What's 3 plus my a? My h. 3 plus my h. Isn't that 4? And this is my a, so a plus h. And look, I got those simple points that I can graph. So 2, negative 1, 4, 0. 2, negative 1, and 4, 0. And I can graph my logarithm. So that's another way you can do it. So, but you got to be cautious. You got to get the log by itself first, and then you can go ahead and switch it to an exponential, and then solve for x, and then pick your y's instead of picking your x's. Okay, so that's how you graph logarithmic functions. Okay, so I'll do some of the homework problems for you. Okay, so here they are, number 39, 43, 51, and 55. So as we look at number 39, we're looking at this logarithm, log base 2 of x. Do that first, and then I add 3. You usually don't see those parentheses around that, but they kind of do it for you, kind of start you off there, so that you know you take the log of x first and then you add 3. And you can see from the oh, I forgot my equal sign. The next one, even though you're not doing it, but 40 is asking you to do this. This one's saying do x plus 3 first and then take the log. So those are different from each other. And again, I forgot the equal sign, but that's good. So here you how you do this problem, right? First you find your vertical asymptote. So that's what makes this 0. Basically that's what your asymptote is saying. And I'm not adding anything to x or subtracting anything to x before I take the log. So that means my vertical asymptote is x equals 0. So we can go ahead and graph that. X equals 0. X equals 0. There's my vertical asymptote. Got that down. Now I need 2 points, right? Well, you can go ahead and pick some numbers, right? We know we can't pick 0 because that's our vertical asymptote. How about 1? So what's log base 2 of 1? 2 raised to what is 1? 2 raised to 0 is 1. Now we can add 3 to that, and so we get 3. So I picked 1, and I got 3. So I picked 1, and I got 3 as my y, so 1, 3. Okay, now can I pick another number? How about 2? 2 is a good one. Because what's log base 2 of 2? That is going to be 1. And then what's 1 plus 3? That's 4. So I pick 2, I got 4. So I pick 2, I get 4. It doesn't cross this vertical asymptote and continues to go up. It doesn't flatten out. It continues to go up to the right. Okay? Because it's always increasing. This is a function, vertical line test, horizontal line test, right? Because the exponential one, like this, passes the horizontal line test, that means that the inverse will be a function, right? And this is a function, the vertical line test. So if your function passes the horizontal line test, that means your inverse will pass the vertical line test, meaning it's a function. Okay? Alright, so next one. Alright, so here's the next one, which is 43, and f of x is equal to log base of a half of x minus 2. So this one's a little more tricky, right? You haven't had one like this yet. So again, what is my vertical asymptote? X equals positive 2, always opposite of this, right? Which is your h, so if you want to write that down, my h is 2. And what's your a? It's 1/2. And then you could use the fact to find your 2 points that we always take 1 and add our h, and then take our a and our h and add those together. Right, so 2.5 and 3, so those would be really good x's to pick, but again, you don't have to. And then you could plug them in, you could solve, and this is always going to get you, when you plug in that x of a plus h, right, so whenever you plug that in, you will always get, for your log part, for just this part, wherever the log is, that's always going to get you your 1, right? So if I plug that in 3, or sorry, it gets you 0. Sorry, it always gets you the y of 0. Whenever you do your 1 plus h, your y will always be 0. Your y will always be 0 when you do this, and when you do the a plus h, you always get an answer of 1. So if I put in 2.5, 2.5 minus 2 is a half, right? Is 0.5 is a half, and 1/2 raised to what is 1/2? That's a 1. It always gets you a 1. Okay, so I could use those 2 points and graph those. But say I don't want to do that because I don't understand what Mr. L-Trell is talking about here. All right, I have no idea what he means by a plus h and add them and do whatever. So we could switch this to an exponential, right? I have my base. This is my y, right? So my y and what I'm taking the log of is going to switch places. So this is going to be my y equals what I'm taking the log of. Now I can solve for x. So 1/2 raised to the y plus 2 equals x. So now you can pick your y's. What am I going to pick for a good exponent? Wouldn't that be 0? So plug in 0. 0 raised to 1/2 is 1. 1 plus 2 is 3, right? So I have that 0.03. Now what's another good exponent to have? How about 1? 1/2 raised to 1 is 1/2. 1/2 plus 2 is 2.5. So I get this point, 2.51. So we can graph. Did I already put that up there? Nope. So we have at positive 2, we have our vertical asymptote, and then at 3, 0. So 1, 2, 3, 0, I have a point, and at 2.5, 1, I have a point. So you might think, hey, what does this look like? It's not going to cross that line, right? But I noticed that from left to right isn't going down. So it's going to continue to go down. It's not going to flatten out. And then this way it's got to approach that vertical asymptote. Right? When you have a fraction as your a, it's going to flip that standard logarithm that looks like this. It's going to flip it about the x-axis, so then it's going to turn like this. Right? Okay, so those are those two. Okay, so here you go for this one. So now this one, you could find out what your vertical asymptote is, which which is x equals 0, and then you could switch this to exponential right away, right? Or you can plug in x's. What's a good x to pick without switching this to exponential? How about 5? Because 5 raised to what is 5? That'd be 1, right? So 5, 1. What's another one could pick? How about 1? 5 raised to what is 1? That'd be 0, right? So I have that point right there, those two. Oops, why am I doing that? Okay, so we have x equals 0, dot, 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 dot. We have 5, 1, 1, 0. So it looks something like this. Okay, and then number 55. Number 55, here's, it's still not even a little bit more to it, but, nope, yep, a little bit more to this one, right? Log base 3 of x minus 1, and then plus 2, y equals, or f of x equals. Okay, here, what's the opposite of this? Is my vertical asymptote. X equals positive 1. So positive 1, x equals 1, vertical asymptote. Now you can start plugging in numbers, or you can switch to an exponential. Let's go ahead and do that. Subtract 2 first. You got to get the log by itself. So y minus 2 is equal to log base 3 of x minus 1, the quantity x minus 1. And now I can switch places. 3 raised to y minus 2 equals x minus 1. Add 1 to both sides. So 3 raised to y minus 2, and then I'm going to add 1 to that, is equal to x. So now I can pick my x's. How about 3? 3 is a good x to pick, right? Because 3 minus 2 is 1, and you get 3 plus 1 is 4. X and y, or sorry, those are y and x's. Y I picked was 3, and I got a 4 as my x. How about, excuse me, how about a positive 2? How about a positive 2? 2 minus 2 is 0, 3 to the 0 is 1, 1 plus 1 is 2, so we get the point 2, 2. So 1, 2, 1, 2, 2, 2, and then 4 as my x. So 1, 2, 3, 4, and then up 3. So it looks something like that. It keeps going. So there you go. So those are all of them, correct? Okay, all done.